Hello, my name is Nicholas Nikolic and you're listening to the Android Book Tutorials. These tutorials are based on the Creative Commons work of Mark Murphy, who kindly released versions of his book, The Busy Coder's Guide to Android Development, and as such are released to Creative Commons as well. I'll read from the book and go through the points directly. You might be warned that this time I cover up to Android 4.4, whereas the original subscription book is updated on a quarterly basis. For completely current versions of Android, please purchase a subscription to Murphy's book at commonsware.com. Basic widgets. Every GUI toolkit has some basic widgets, field, label, buttons, etc. Android's toolkit is no different in scope, and the basic widgets will provide a good introduction as to how widgets work in Android activities. We'll examine a number of these in this chapter. Common concepts. There are a few core features of widgets that we need to discuss at the outset before we dive into the details on specific types of widgets. Widget attributes. As mentioned in a previous chapter, widgets have attributes that describe how they should behave. In an XML layout file, these are literally XML attributes on the widget element in the file. And we take a look at that. So, for instance, layout width match parent of this relative layout. Text view, layout width, wrapped content. In an XML layout file, these are literally XML attributes on the widget's element in the file. Usually, there are corresponding getter and setter methods for manipulating this attribute at runtime from your Java code. If you visit Java docs for a widget, such as the Java docs for text view, you'll see an XML attributes table near the top. Let's go ahead and do that. And here they are. This list of all attributes defined uniquely on this class, and the inherited XML attributes table that follows lists all those that the widget inherits from a superclass such as view. Of course, the Java docs is also a list of the fields, constants, constructors, and public protected methods that you can use on the widget itself. This book does not attempt to explain each and every attribute on each and every widget. We will, however, cover the most popular widgets and the most commonly used attributes on those widgets. Referencing widgets by ID. Many widgets and containers only appear in the XML layout file and do not need to be referenced in your Java code. For instance, a static label, text view, frequently only needs to be in the layout file to indicate where it should appear. Anything you do want to use in your Java source, however, needs an Android ID, Android:ID. The convention is to use @ plus ID / and so on as the ID value, whereas the ... ellipsis represents your locally unique name for the widget in question. For the first occurrence of a given ID in your layout file, the second and subsequent occurrences in the same layout file should drop the plus sign. Android provides a few special Android:ID values of the form Android @Android:ID /... We will see some of these in the various chapters of the book. There's a interruption M dash actually. I'm not sure if that's actually typographic or whether or not it's meant to be part of the symbol. To access our identified widgets, I guess I'll find out. Use find view by ID, passing it with a numeric identifier of the widget in question. That numeric identifier was generated by Android in the R class as r.id.something, where something is the specific widget you are seeking. This concept will become important as we try to attach listeners to our widgets. For instance, finding out when a checkbox is checked, or when we try to reference widgets from other widgets in the layout XML file, for instance with relative layout. All this will be covered later in the chapter. Size. Most of the time, we tell Android how big we want our widgets to be. Occasionally, this will be handled for us. We'll see an example of that with table layout in an upcoming chapter. But generally, we need to provide this information ourselves. To do that, we need to supply Android:layout width and Android:layout height attributes on your widgets in the XML layout file. And here they are. These attributes values have three flavors. 1. You can provide a specific dimension, such as 125 dip, to indicate the widget should take up exactly a certain size. Here, 125 density independent pixels. 2. You can provide wrap content, which means that the widget should take up as much room as its content require. For instance, a text view label widget's content is the text to be displayed. Or 3, you can provide a match parent, which means that the widget should fill up all the remaining available space in its enclosing container. The latter two flavors are the most common, as they are independent of screen size, allowing Android to adjust their view to fit the available space. Okay, wrap content, match parent. Note that you also see fill parent. This is an older synonym for match parent. Match parent is a recommended value going forward, but fill parent will certainly work at this time, at the time of the writing of this document. This chapter focuses on individual widgets. Size becomes much more important when we start combining multiple widgets on the screen at once. So we will be spending more time on sizing scenarios in later chapters. The layout prefix on this attribute means that these attributes represent requests by the widget to its enclosing container. Whether those requests will be truly honored will depend on a bit on whether other widgets there are in the container and what their requests are. Assigning labels. The simplest widget in the label is the label, referred to in Android as a text view. Like in most GUI toolkits, labels are bits of text not editable directly by users. Typically, they are used to identify adjacent widgets. For instance, a name label before a field where one fills in a name. In Java, you can create a label by creating a text view instance. More commonly, though, you'll create labels in XML layout files by adding a text view element to the layout. With Android, with an Android :text property to set the value of the label itself. If you need to swap labels based on certain criteria, such as internationalization, you may wish to use a string resource reference in the XML instead. For example, @string/label. For example, in our last tutorial, we are still using an automatically generated res layout main XML file, containing, among other things, a text view. And there it is in the text, and here it is in the code. And then we have a little tiny bit on the layout editor in Eclipse, which I'm going to skim over, and we'll do it in the code. And there wasn't any changes. Notable text view attributes. Text view has numerous other attributes of relevance for labels, such as Android : typeface to set the typeface of the label, for instance, monospace. Android text style to indicate the typeface should be made bold, italic, or bold and italic. Android text color to set the color of the label's text in RGB hex format, or ARGB for translucent ARGB hex format. These attributes, like most others, can be modified through the Properties pane. Let's find the Properties pane. So I'm just taking a look around to see well, here are the properties. I'll get back to that. I'll fix that between videos. These attributes, like most others, can be modified through the Properties pane. And when we go back to the Design view, the Properties pane is right here. For example, the basic label sample in the basic label sample project, you'll find the following layout file. And then here we have the layout file. And just that layout alone, with a stub Java source provided by Android's project builder and appropriate string resources, gives you this. A commanding button. Android has a button widget. With your classic push button, click me and something cool will happen. Which is your classic push button, click me and something cool will happen widget. As it turns out, button is a class of text view, so everything discussed in the preceding section in terms of formatting the face of the button still holds. For example, in the basic button sample project, you'll find the following layout file. And the linear layout is the parent, button is the child. Just that layout alone, with the stub Java source provided by Android's project builder and appropriate string resources, gives you a button. Unfortunately, these are all Eclipse oriented, so we're going to need to skim through it, but the corresponding Android Studio requirement would be to bring in a layout and then bring in a button from the widgets. So here's button. You know what? Let's go ahead and spend a little time. We have some time to fix this problem now that I think about it. Seems that we have a layout issue. It says an exception is raised during rendering. So far, I'm not seeing if I run it, let's see if an exception is still raised. No. Okay, so we're good. This is an important detail. Tracking button clicks. Buttons are command widgets. When the user presses a button, they expect something to happen. To define what happens when you click a button, you can define some method in your activity, that holds the button, that takes a single view parameter, has a void return value. In your layout, on the button element, you can include an Android onClick attribute with the name of the method you defined in the previous step. One or the other. Fleeting images. Android has two widgets to help you embed images in your activities. Image view and image button. As the name suggests, the image-based analogs to text view and button respectively. Each widget takes an Android src attribute in an XML layout to specify what picture to use. These usually reference a drawable resource. For instance, @drawable/icon, image button, a subclass of the image view, mixes in the standard button behaviors for responding to clicks and whatnot. For example, take a peek at the main.xml layout from the basic/image view sample project. And that's not an image button, that is just an image view. And it shows the Android ID to be ID icon, and the Android:/src to be @drawable/molecule. And so the image name molecule, let's say molecule.png, would be what's shown. That's right here. fields of green or other colors. Along with buttons, labels, and buttons and labels, fields are the third anchor of most GUI toolkits. In Android, they are implemented via the Edit Text widget, which is a subclass of the text view used for labels. Along with the standard text view attributes, for example, Android text style, Edit Text has others that will be useful for you in constructing fields, notably Android input type to describe what sort of input your edit text expects, numbers, email addresses, phone numbers, a thorough explanation of Android input type and its interaction with input method editors, aka soft keyboards, will be discussed in an upcoming chapter. For example, the basic field sample project. Here's an XML layout file showing the edit text. Note that we have Android input type equals text multiline, so we'll be able to enter several lines of text. We also have defined in the initial text to be the value of a license string source. The result, once built and installed into the emulator, is as follows. There's that image. Okay, more things for Eclipse. Well, you know what? Let's just toss it in. So we're going to get back into design view. Text fields, plain text. Edit text is a thin veneer over text field. And instead we're going to go to the text field. I'm going to quick restart Android Studio. This exception is still being raised. Let's see if it's out of here. Alright. So we're just going to create a new layout resource file. Let's go to file name of OL. It is a linear layout. Okay, well, I'll fix this later then. Alright, notable edit text attributes. The request focus item in the context menu, right click over the edit text widget, allows you to indicate that this edit text should be a widget that receives the focus when this layout is loaded onto the screen. By default, the focus goes to the focusable widget that is first, closest to the upper left corner, but you can override this using this attribute. The hint item in the properties pane allows you to set a hint for this edit text. The hint will be shown in light gray in the edit text widget when the user has not entered anything yet. Once the user starts typing in the edit text, the hint vanishes. This might allow you to save screen space, replacing a separate label text view. The input type item in the properties pane allows you to describe what sort of input you are expecting to receive in this edit text, lining up with many of the text fields. You can drag the palette from the palette into the layout. More common concepts. All widgets, including the ones shown above, extend view. The view base class gives all widgets an array of useful attributes and methods beyond those already described. Padding. Widgets have a minimum size, one that may be influenced by what is inside of them. So, for example, a button will expand to accommodate the size of its caption. You can control this size using padding. Adding padding will increase the space between the contents and the edges of the widget. Padding can be set once in XML for all 4 sides, Android padding, or on a per side basis, Android padding left, etc. Padding can also be set in Java via the setPadding method. The value of any of these is a dimension, a combination of a unit of measure and a count. So 5 pixels, 5px is 5 pixels, 10 dip is 10 density independent pixels, or 2 mm is 2 millimeters. Margins. By default, widgets are tightly packed, one next to the other. You can control this via the use of margins, a concept that is reminiscent of the padding described previously. The difference between padding and margins comes in terms of the background. For widgets with transparent background, like the default look of text view, padding and margins have a similar visual effect, increasing the space between the widget and the adjacent widgets. However, for widgets with a non-transparent background, like a button, padding is considered inside the background, while margins are outside the background. In other words, adding padding will increase the space between the contents. The caption of a button and the edges, while adding margin increases the empty space between the edge and the adjacent widgets. Margins can be set in XML, either on a per side basis, Android, layout margin top, or on all sides via Android, layout margin. Once again, the value of any of these is a dimension, a combination of a unit of measure and a count, such as 5px or for 5 pixels. Colors. There are 2 types of color attributes in the widget, in an Android widget. Some, like Android background, take a single color or a graphic image to serve as the background. Others, like Android text color on text view and subclasses, can take color stateless, including via the Java setter, in this case set text color. A color stateless allows you to specify different colors for different conditions. For example, when you get to selection widgets in an upcoming chapter, you'll see how a text view has a different text color when it is the selected item in a list compared to when it is in the list but not selected. This is handled via the default color state list associated with the text view. If you wish to change the color of the text view widget in Java code, you have two main choices. Use color state list .value of, which returns a color state list in which all states are considered to have the same color, which you supply the parameter of value of method. This is the equivalent of the Android text color approach, to make the text view always a specific color, regardless of the circumstances. Create color state lists with different values for different states, either via the constructor or via an XML drawable resource. Other useful attributes. Some additional attributes on a view are most likely to be used include Android visibility, which controls whether the widget is initially visible. Android next focus down, Android next focus left, and next focus right, focus up, which control the focus order if the user uses the D-pad, trackball, or similar pointing device. Android content description, which is roughly equivalent to the alt attribute of an HTML image tag, and is used by accessibility tools to help people who cannot see the screen navigate the application. This is very important for images, for widgets like image view. Useful methods. You can toggle whether or not a widget is enabled via set enabled, and see if it is enabled via set is enabled. One common use pattern for this is to disable some widgets based on checkbox or radio button selection. You can give a widget a focus via request focus and see if it is focused via is focused. You might use this in concert with disabling widgets as mentioned above to ensure the proper widget has focus once your disabling operation is complete. To help navigate the tree of widgets and containers that make up an activities view, you use getParent to find the widget or parent widget or container, find view by ID to find a child widget with a certain ID, getRootView to get the root of the tree. For instance, what you provided to the activity to set the content view is via set content view. Visit the trails. You can learn a lot more about Android's input method framework, what you might think of as soft keyboards, in a later chapter. Another chapter in the trails covers the use of fonts to tailor your text view widgets and those inherited from them, like a button. Yet another chapter in the trails covers rich text formatting, both for presenting formatted text in a text view, inline boldface, and for collecting formatted text from the user via customized edit text. Let's scroll on. Debugging crashes. We're going to go ahead and break it off here. Thank you, and you all have a great night.